Okay, I just wanted to make a quick update on what I've been working on lately. What I wanted to see if I could do, and this is kind of in the same vein as what the Stratix does, with its ADS-B radios and its AHRS board, sending data via Wi-Fi to common EFBs like ForeFlight and whatever. Uh, this is kind of the same idea, except for instead of sending ADS-B traffic and weather data, and if your Stratix has an AHRS board, it kind of duplicates that. But what I mainly wanted to do was the airspeed, but also see if I could combine that together with an attitude sensor and see if I could send reliable data and compare that to what's the instruments in the plane, and see how accurate it is, or even more accurate than what's already in there. So basically, what this is a 3D robotics airspeed sensor, running through those plastic tubes to a pedostatic system with that pedo tube sticking out the front there. This screen on top. It's just for being able to change settings on the system itself in the field without having a terminal or anything hooked up to the Raspberry Pi. I can just control it through a simple user interface right in the field. Over here, this is the Adafruit BNO055 9-axis attitude sensor. It also has a temperature sensor on it, and a pressure sensor, and a magnetometer. We'll see how well all those work in the real world. What I'm really interested in is how well that magnetometer performs compared to the compass in the plane. I know it'll outperform the heading indicator because I have an older Cherokee, and it constantly needs to be adjusted against the compass. Over here, this is just an Adafruit charge controller, and that switch just runs a shunt on the charge controller to tell it to just charge the battery, or let power run to everything. Adafruit makes some pretty slick products. I'd recommend them to anybody who's interested in this kind of stuff, because they really make some cool stuff. Under here, I've just got a giant lithium polymer battery that runs everything when I don't have a power supply. And that's about it as far as parts go. Basically, this here is connected to the Raspberry Pi. The attitude board is connected to the Raspberry Pi over the serial port. This has to be in UART mode. In the little bit of research that I did, this has to be in UART mode instead of I2C mode. There's a clock issue. And it seems to work fine in UART mode, and that way I don't have to double up on the I2C port that the 3D robotics sensor uses. So this is kind of all on its own on the I2C interface, and that's about all there is to it. The only software that I've really written is just to kind of initialize everything and set up some initial stuff on the screen. So there's not a whole lot to show as far as that, but I do have everything wired up and tested, and everything works, and I can read all the sensors. I just don't have the software written that collates everything together and sends it to a Wi-Fi stream to a tablet that can read it. I kind of want to format it so that the data stream is just going out GLD90 format. The same thing that ForeFlight recognizes. So if you just wanted to use it with ForeFlight and nothing else, you could just use their attitude indicator, and you're ready to rock and roll. I'd like to see if I can build a tablet that I can display everything on separately, just because it's a cool thing to do. There's no actual huge need for it. Other than you could have a backup glass panel display on your in your cockpit. That's about all there is to this, and I it should be pretty easy. Once I have all the software written to take this back apart and wire it nice and neat and get it all fit into a nice small case that isn't too draggy, so you can just clip it underneath your wing, and you've got an airspeed and attitude and magnetic reference system. So hopefully this pans out, and I'll post another video when I make a little more progress with the software. Thanks for watching.